Dear friends, in this tutorial, we are going to learn about various resistances associated with a diode. These are the points covered in this tutorial. We have already seen in previous tutorials that the diode characteristics is not linear, so the resistance also changes from one region to another. We will start with DC or static resistance. The application of a DC voltage to a circuit will result in an operating point, and this operating point will not change with time. From this VI characteristic, the resistance of the diode at the operating point can found simply by finding the corresponding levels of the VD and ID. RD is equal to VD divided by ID. The DC resistance level at the knee voltage and below will be greater than the resistance level obtained from the vertical rise section of the characteristics. For the reverse bias region before the breakdown occurs, the value of RD will naturally be very high. In general, the lower the current through the diode, the higher the DC resistance level. Now, we will see what is AC or dynamic resistance, and how it is calculated. If we apply an AC signal, the varying input will move the instantaneous operating point up and down of the characteristic, and thus define a specific change in current and voltage, as shown in this figure. Here the Q point is the DC operating point. The Q point is derived from the word quiescent, which means still or unvarying. A tangent line is drawn to the curve through the Q point as shown in this figure. The change in voltage, delta VD, or change in current, delta ID, should be made as small as possible. Therefore, AC resistance is given by small rd equal to delta VD by delta ID. So, lesser the value of delta VD, the lower the resistance, in general lower the Q point of operation. That is smaller current, or voltage, the higher the resistance. Let us consider the diode equation, and derive an expression for RD. Substituting EDA equal to 1, for silicon and germanium for vertical slope section of the characteristic, we have small k value equal to 11,600. From the equation 7c, it is clear that there is no need to have the characteristics, or to draw a tangent for finding the value of RD. If we include the body resistance, RB, of the semiconductor, the equation 7c becomes: the value of RB ranges from 0.1 ohm for high-power devices, to 2 ohm for some low-power, general-purpose devices. Now let us consider the third type, that is, average AC resistance. If the input signal is sufficiently large to produce broad swing as shown in this figure, the resistance associated with this region is called the average AC resistance. The average AC resistance by definition is determined by a straight line drawn between the two intersections established by the maximum and the minimum values of the input voltage. Here also, we can observe that, the lower the level of current used to determine the average resistance, the higher the resistance level. Thank you for watching. Let's meet in the next tutorial video. Please like, share and subscribe to my channel.